back, everyone, to Web Programming with Python and JavaScript, and welcome to our final lecture. So we've talked about a lot over the course of Web Programming with Python and JavaScript, everything from version control to designing what a web page looks like using HTML and CSS, and then moving into programming languages like Python and JavaScript that are used on the server side and on the client side in order to build and design web applications. And where I thought we'd conclude today is by talking a little bit about security, about making sure that our web applications are secure, thinking about what sorts of security vulnerabilities can come about when we're thinking about web applications and deploying them to the internet, and how we can best defend against those potential vulnerabilities. And in doing so, we'll be taking a look back at all of the topics that we've talked about so far in this course, going from Git to HTML to looking at Flask, SQL, our API design, thinking about programming in JavaScript, using Django as a library later on, testing with continuous integration and continuous deployment in addition to scalability, and looking through all of these past topics one at a time and thinking about where security vulnerabilities might arise in any of these potential areas and how we might start to think about defending against them. Some of these things will be things we've alluded to or talked about a little bit over the course of the semester so far, but today we'll really take an opportunity to look at all of these topics in a little more depth and think about what security vulnerabilities could come up in the process of dealing with any of these areas within web programming. So where I thought we'd start is at the very beginning by talking about Git. So we began this semester by talking about version control using Git and GitHub in particular as a way of hosting code online in a place where different people from around the world can have shared access to a repository of code where they can push code to it, or they can pull code from it using different branches and features like pull requests in order to better collaborate on code. And GitHub is really built upon this idea of open source software where the code isn't hidden from people, but is available for potentially anyone who wants to look at that code, to see that code, and if they want to, propose pull requests or suggestions or changes to that code. And so let's think about open source software just as a high-level idea right now. What are some security benefits of open source software, and what are some potential security concerns that might arise? Sure. Great, lots of people can see it. Right, and that has implications on both sides of things when it comes to bugs, which means that when you have a lot of different eyes all looking at the same code, there's a possibility that someone else might catch a bug that you missed when you were writing the software. But on the flip side, of course, if someone is able to spot a vulnerability in your code by reading it, and they don't tell you about it or any of the other maintainers of the code, now they're potentially able to take advantage of a security exploit in your code, something you didn't see coming before, and something that they wouldn't have otherwise known about had the code not been open source. So open source software in that sense can sort of be a double-edged sword, where you have to be careful that with a lot of people all looking at the code, there's potential both for a lot of people to be able to help you in finding bugs and making security improvements to your code, but also areas where there might be vulnerabilities. And over the course of today, we'll be looking at some of those potential vulnerabilities that can exist inside of our web programming or web programs, and taking a look at how we might start to try to defend against them. What other security considerations might come up when we're using Git and GitHub in particular, if we're hosting our code online? You might think that with open source software, we might be able to just make our repositories private. So GitHub has the option of making repositories private so that only certain people have access to your repository, so not everyone can potentially see it. But what dangers still might arise there? Multiple possibilities. Sure. Sure, if someone had access to your GitHub account, all your code is now stored online, which means if some enterprising hacker is able to somehow gain access to your account, then they might be able to take advantage of that. And so, for a long time, most websites have operated under a model of username and password being the way that you log into a website, and increasingly there are ways that hackers try and bypass that, by trying to either guess passwords, by guessing frequently used passwords, or by trying to just guess many different passwords, trying thousands or millions of different password combinations in the hopes of at least getting access to some person's account. And so if hackers are doing that, trying to guess at passwords very quickly in order to try and gain access to accounts, what can web applications do in order to defend against that? In order to defend against hackers that might be trying to get into other users' accounts unauthorized? Sure. Great. Great, so different possibilities exist. One might be placing a limit on the number of times you can try to log in any period of time. Maybe you can only log in or attempt to log in 5 times, and if you miss 5 times, then you have to wait potentially an hour until you're able to log in again, for instance. So many applications do that. And then you also talked about other authentication systems. So what other authentication systems could there be? Great, so an increasingly popular form of authentication now is two-factor authentication. The idea that it's not just enough to log in with a username and a password, but you might also want to log in with something else, something that is physically on you, like a phone, for instance, where after you type in your username and password, code is texted to your phone, or you use an app on your phone in order to get a special code, and then you have to type in that code, so that even if an attacker potentially knows your password, either by hacking into some database and finding the password or just by guessing it luckily, they're still not going to be able to access your account because they still have this added step of having to go through some two-factor authentication code where they now need to type in a particular code that is only available to someone that physically owns the device, like a phone, and that can also help to improve security as well. And so GitHub, for instance, has an opt-in two-factor authentication where you can enable that for your account in order to make your GitHub account more secure, and other websites are increasingly offering two-factor authentication as well as just an additional means of trying to secure your accounts, and web applications are beginning to use that as a security measure as well. But let's think more broadly, not just about GitHub, but about Git in general, and this idea of version control, and making changes and committing and saving those changes. And when we're thinking about pushing our commits to the internet, taking our changes that we've made in a GitHub repository and pushing them online, we want to be careful that sensitive information, like a password or an access token for some service, doesn't end up inside of a repository. Because if it does, then if it gets pushed online, regardless of whether that repository is public or not, then there's a potential that other people might be able to see that access token when they probably shouldn't. And so imagine a situation where you're working on a repository and you've made some commits, and maybe accidentally you put a password or some access token that you didn't mean to inside of one of the files, and you commit that file. And so credentials have now been exposed in one of the commits inside of your repository. And then later on down the line, you realize that mistake. You realize, oh, wait a minute, I put credentials inside that repository when I probably shouldn't have. And you make another commit, removing those credentials from the file. So you add another commit, removing those credentials, and now those credentials are no longer in the head of the repository. You've taken them out, you've committed that removal. Is that secure? No, I see you shaking heads. Why not? Great, because of Git's version control system, the fact that it's saving every time you make a commit, it's saving your entire history, which means that even though if you look at all of your files in their current state now, those credentials are not there, anyone who has access to that repository has access to the full history of commits. They can go back and look at your previous commit messages, the previous files you've changed, and what your files looked like at every stage along the way. And so once you've exposed those credentials, now even if you make another commit after that, those credentials are still going to be there. And so there are ways around this. There are ways of reverting back to a previous commit and pruning away all the extra commits, and then what we would call like force pushing those commits back to GitHub in order to update it. But generally, once you've pushed code to GitHub, you might want to imagine all of that code is potentially compromised. So if you had passwords or security credentials or other keys inside of your repository that you accidentally pushed to GitHub, probably a good idea to just exchange those credentials altogether in order to get new ones, because there is the potential that those credentials could be compromised once they're pushed. And so those are some security considerations that might come about when we're thinking about Git and GitHub. But let's take a look now to actually writing code and taking a look at HTML. So HTML, remember, we were using at the very beginning of the semester and all throughout the semester in order to design web pages. They were just consisting of tags, where we had our body tags and different tags for creating lists or creating forms or creating buttons and so on and so forth. What security vulnerabilities might come about from just purely HTML? Or how might HTML be used to trick users into doing something that a malicious attacker might want them to do? Yeah. Great. Inside of a browser, for instance, you can inspect on a website and you can take a look at all of the code. And so what are the implications of that? Well, that means that if I wanted to, I could, for instance, go into my browser and go to, I don't know, bankofamerica.com, for instance. And I could pull up, okay, here's Bank of America's website, which is really just HTML that's been rendered onto my screen. And if I wanted to know, what code is Bank of America using in order to make any of this stuff happen, I could reasonably control-click on this site, click on View Page Source, and what that pulls up for me is a whole bunch of HTML, it's a whole bunch of it, and I don't really know what all of it does, but if I just take it all and copy it to my clipboard, and I go into a web browser, or a text editor, and create a new file, I'll call it bank.html, and I'm just going to paste in all of that code that I just copied off Bank of America's website. I didn't have to write any of it, just copied it straight from there. Now if I go ahead and open bank.html, this file I just created, now I've effectively recreated Bank of America's website just by copying their HTML, and if I now host this from my own web server, for instance, I might be able to trick unsuspecting users into thinking that this is actually Bank of America's website, because just at first glance it looks quite reasonably like the same thing because it's the exact same HTML. And if I'm really enterprising, I can think about actually trying to make modifications to this code in order to even better be able to try and maliciously take advantage of a user who might unsuspectingly be arriving at this site, not realizing that it's not the actual Bank of America website. I might, for instance, take this forgot passcode button down here, which is probably a link to some page where they might type in their email address or try and type in some new passcode that they want, for instance. And I might just take this HTML file and I'll just search for forgot passcode. And okay, here it is. Here's forgot passcode. And if we notice, it's located inside of an A tag, an anchor tag, which has this href attribute, which is going to be where the user is linked to if they were to ever click on that I forgot my password button. And so if I take this link, this secure.bankofamerica.com/login something, and instead of linking to that, link to, I don't know, https cs50.github.io/web or whatever other page I want to redirect the user to. Now if I refresh this site, it looks like Bank of America's website once again, but when they go over here and they try and click on this forgot passcode button, now they're taken to our website, or whatever website I want to take the user to. I can modify the HTML that they have in order to direct them anywhere. And so that's sort of one of the common ways that attackers are able to use HTML to try and trick users into doing something. In particular, noting the fact that you can take a link and make it look like it's going anywhere, but really take the user to somewhere that you want. I can have something like this, where if I just have href equals URL1, where URL1 is where I want the user to be taken to, and URL2 is just the text that appears to the user, then the user might reasonably be tricked into thinking that they're going to URL2, when in reality, they're going to URL1. And so a simple example of that might be inside of link.html here, where in link.html, it's a very simple HTML website, wherein inside of my body tag, I have an anchor tag, which is just going to be a link, and the href of that link is this course's website, for instance. But in between the A tags, what I have is just google.com, for instance. And so what that means is that if I were to open up link.html, for instance, what the user sees is something like this, a page that just has a link to Google, and they might reasonably think that clicking on that link should take them to Google, when in fact when they click on that link, they're taken here instead to the course webpage. And so you can imagine how this might actually be able to be used in order to create potential exploits. That if someone were to take Bank of America's URL, and I go to link.html and say, all right, we'll put Bank of America here, and in the href instead put bank.html, for instance, which is the link to the file that I created copying Bank of America's code. Now suddenly, when I open up link.html, I get a link that says, looks like it's linking to Bank of America. I click on that link and I get a page that looks like Bank of America's website. And if I click on forgot my passcode, now I'm redirected to some other site altogether. And so these are common ways that exploits are able to happen by taking advantage of security vulnerabilities like this, where we're really just relying on people not being aware of the fact that clicking on a link might take them to somewhere else different altogether. And so how do you defend against things like this? Well, one good strategy from the user end is just to be careful about the links that you're clicking. In Chrome, for instance, if you hover over a link, down in the lower left, you can see this. It's in small text, you might not be able to see it, but this is the actual link that this link is going to be going to. So you can't always trust what the text is. You might want to look very carefully at where that link is actually taking you. And so these are just some examples of HTML being used in order to create potential security exploits.